Hello again. Today what we're going to do is we're going to talk about the slope-intercept form of a line, right? So we want to be able to graph one of these equations, right, on a coordinate plane. So we've already talked about the slope and we talked a little bit about y-intercept, right? So slope is just telling us how fast a graph is increasing or decreasing, right, depending on the situation. As for a y-intercept, that's where our line crosses the y-axis on a graph, right? The y-axis, again, being the one that runs up and down. So then we've got the slope-intercept form of a line, right? So this is going to be pretty darn important, so I'm going to zoom in on it just so it's real easy to see. Our slope-intercept form of a line is going to look something like this. It's y equals mx plus b, right? So the reason they call it slope-intercept form is because it tells us about the slope, which is the m. Right? So our slope is right in there. And it also tells us about an intercept, specifically the y-intercept b. Right, so when we're working on slope-intercept form, right, everything that's written there in black is going to stay the same, right? So we're going to have y equals something with an x, and then plus our, or sometimes in some cases minus our y-intercept, right? So if I'm asked to identify the slope and y-intercept of this equation, this might seem like one of those things where I'm pulling your leg, but honestly, it's like those books where it's like, find X, and then some guys are like, I found it, there it is, right? That's actually what we're doing here, right? To find the slope, it's right there. Our slope is just that number that's hanging out in front of X. In this case, it's 3. Our y-intercept, in this case, is 5. And that's it. That's all we're doing. Right? But honestly, being able to tell where these things are is real important for these, right? Sometimes there are negatives involved, right? But same general idea. The slope is this entire thing of -2, right? So if there is a negative with the slope, you do want to grab that. It's going to be kind of the same idea for the y-intercept. If that y-intercept is there's subtraction going on there, it is a negative y-intercept. You'd grab the entire thing, -4. All right. Try this one out on your own, right? See if you can figure out which one's which. So hopefully you said that 3/5, that's the slope. And then over here we have -9 as our y-intercept. All right. So again, fractions are actually great as the slope, right? Remember, rise over run. That's something we've done in the past, right? That's what we're going to be using. As for the y-intercept, it is important to note whether it's positive or negative, so be careful of those subtraction signs. For this last one, to figure out the slope, it's just whatever's in front of x, right? It's a negative fraction, which looks gross, but again, if we're graphing it, it's not that bad, right? So our slope is -1/2. Our y-intercept is +11, right? And that, again, that's all we're doing with those, right? So, hopefully, it doesn't seem so bad, right? Just pointing to these different pieces for the slope and the y-intercept. We're going to try some graphing. So on here, right, what we're going to do is we're just going to fill in these blanks. These are our steps that we're going to take in order to actually graph slope-intercept form. Our very first step is that we are going to start by plotting the y-intercept. And so y-intercept comes up first. So you're just going to go either up or down on your y-axis, plop your y-intercept on there, and then we're going to move on. After that, we need to use the slope, and we're going to do rise over run to get a second point, right? So to graph the line, which is our third step, we need 2 points so that we can connect them with the line, right? So plot the y-intercept first, figure out what your slope is, and then rise over run to get a second point, right? And actually something I want to make sure I mention, we want to rise over run from the y-intercept, right? And you'll kind of see what I'm talking about when we go ahead and take a look at one of these problems together, right? You don't want to go from the origin when you're using your slope. You want to take that point you already had, the y-intercept, and rise and run from there, okay? So first things first is, we got y equals 2x minus 4, right, I'm going to identify what my different pieces are, right? So my slope is 2, right? We're going to do something a little funky with this 2, right? Because 2, doesn't have a rise and run, we're going to think about it as 2 over 1. So we have a rise and a run, right? As for our y-intercept, again, be careful. This does have a negative with it, right? It's -4. So my y-intercept is at -4. Okay. So we've got that information. All we got to do is pop it on the graph. So again, we're starting with our y-intercept just like those steps up at the top of this page say to do. Right? We're going to go to -4 on my y-axis, and that is going to be my y-intercept where that red dot is. Okay. After that, I'm then using my slope. And again, I want to start from that point we just graphed and do rise over run from there. So in this case, right, 2 over 1, if it helps, you can write out rise over run there. It's telling me to go up 2, so I'm going to hop up 2 spaces and then run 1 space over. Right, so it's going to give me a second dot right where that blue one is. Right, and just to make everything a little less clear, I'm going to get rid of those little hops. And that's it, right? The only thing we got left to do is graph the line, which is not too bad, right? Oops. It is bad when I flip the page around, but that's okay. So that is the last thing we got to do. Take some sort of straight-edged object. A ruler, if you have one, would be excelente. And just connect the dots. Zoop, right on through. And again, something we talked about with the last lesson on graphing from tables. Use the entire graph, right? It's going to be nice when we get to things later on in math, right? Not necessarily this trimester, but in the future, it's a good habit to get into, to use the entire graph. Right? Let's try another one out. Right. So same kind of deal here. We're going to start off by grabbing my information. My slope is -4. All right, same deal as on the last one. We're going to turn that into -4 over 1. Right, so that we have a rise and a run to work with. My y-intercept in this one is +7. So that's all I need, right? Let's pop over to the graph. So we're going to go up to 7 on my y-axis and pop a dot on there, right? So all the way up at 7. After that, what I need to do is do the rise and run, right? So in this case, we have -4 as our quote-unquote rise. What that's telling me is that I need to go down 4. So 1, 2, 3, 4 down, and then 1 over, right? Again, I'm going to get rid of those little hops just to make everything look a little cleaner here. So we should end up with our second dot right down there, right? We went down 4 and over 1, right? The 1 was a +1, so we went to the right, right? Last but not least, connect the dots, and then we're done. It really is not so bad, I hope. Right? Obviously, if you're looking at this and you're like, "Oh no, I don't get it," right? That's okay, right? That's what I'm here for. So when you see me in person, be sure to ask about it, right? Maybe it'll also click a little bit later on as we go through a couple more problems together. Okay. So same kind of deal here, right? What I'd like you guys to do is try this one out on your own, right? See if you can do it. So hopefully you tried that. My slope is 2/3, right? It's already with a rise and a run. That's pretty nice. My y-intercept is +3, right? If you want to do what I'm doing, put that little kind of bracket underneath it to make sure that, like, all right, I'm looking at not just the number, but also the symbol in front of it. It's not a bad idea. All right, over to the graph. Y-intercept up at +3. My slopes tell me to go up 2 and over 3 from there, right? Again, don't go from the origin. We're going up 2 and over 1, 2, 3 from that y-intercept. And last but not least, make the line, and then we're good. Oops. If I can get my ruler lined up all nicely. Hey, look at that. Not too bad. Okay. So, let's keep on going. So again, one where I'd like you to try it on your own, right? See if you got it. hopefully you tried that out. We got our slope, which is -3/5. Right? And actually, this is something worth talking about. If you got a little bit stuck with the slope, that's okay. So when you have a negative in front of a fraction, like that -3/5 x, right? That negative can go either on the top, like I did it over here, or what you could do is you can also put it on the bottom, right? You could do it 3 over -5. That second way that I just wrote it is not something that we really use very often, right? So we could do it that way, but I would not recommend it, right? It's better to keep them on the top because that's what you're going to see most often. It's usually what people, get most used to. So switching it up is a little scary. As for our y-intercept, it is +8. So over here on the graph, I'm going to go up to +8 on my y-axis, pop a dot on there, and that's my y-intercept. My slope is telling me to go down 1, 2, 3, so zoop, and over 5. 1, 2, 3, 4, 5, to get a second dot right over there. All right. After that, again, just connect the dots. That's all we're really doing here is connecting 2 dots. Right? It's the where the dots are that's the hard part. Yeah. And then we get into something that might be a little tough, right? So let's kind of talk through this. So this one we're going to talk through all start to finish together. So my slope is 9/5, right? 9 over 5. My y-intercept is 4, +4. So you might notice I left a whole lot of room to the side of there, right? We're going to be writing a little bit more there. So my y-intercept is up at 4. So I'm going to go up 1, 2, 3, 4 there. And then comes the trouble. My slope is 9/5. That's telling me to go up 9 and over 5. So let's give it a shot, right? Up 1, 2, 3, 4, 5, 6. Uh-oh. Oh, dear. We ran out of space. So this is something that may happen depending on what you're graphing. So let's talk about what to do. So let's kind of backtrack a little bit. Let's kind of take a break from that. Hopefully you'd agree with me that, if I had a negative number divided by another negative number, the two negatives would end up canceling each other out. We could write it as a positive number, right? So what we've got here is we have 9/5, right? Hopefully you would agree with me that I could write that also as -9 divided by -5, right? Those are actually the exact same thing, right? Those negatives would normally cancel each other out, right? But those are the same thing. So when we're graphing, we can kind of use this as a little cheat code, right? Instead of having to go up 9 and right 5, -9 over -5 is telling me to go down 9. And because that 5 is negative, we're going to go left 5. Okay. So let's take a look at what that would look like. So down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And left 5. 1, 2, 3, 4, 5. So we're going to get that second dot down there. Right? So that actually works out, right? It's something that fits on our graph. And then if I think about it kind of backwards again, if I was trying to figure out the slope between these 2 points, right, and I go from the black point to the red point, I would have to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I'd have to go over 1, 2, 3, 4, 5, right? It still comes out as 9/5 for the slope, right? So either way we do it, it will end up being okay. I wouldn't do this unless you have to. It can be a little confusing, right? But this is an option that's available to us if we do run into a bad situation, right? So after that, all we got to do, pop the line all together, and then we're done, right? So again, these ones don't come up super duper often where you have to, go all topsy-turvy with the slope like that, right? But that is a strategy that is really helpful to know about. Okay? And we're almost there, right? We got a little bit more to talk about. And then I will shut my yap. Oy, oy, oy. So, this looks weird. If I'm trying to figure out my slope and my y-intercept, I might have a little bit of trouble, right? My slope It doesn't look like there's any number there, right? But what we know is that x is the same thing as 1x, right? Remember, we've had an invisible 1 there in the past. So my slope is actually just that 1, right? Again, because we want to rise and a run, we're going to think about it as 1 divided by 1, but it's all the same, right? Our slope is 1. After that, I still need a y-intercept. And just like the slope, there isn't a number there, right? Like, what are we supposed to do? So what we can do here, right, is, would you say that 1x and 1x plus 0 are the same thing? Hopefully you would, right? Adding 0 doesn't change anything, right? 1x and 1x plus 0 are the exact same. So what we can do is we would say that 0 is our y-intercept, right? If you ever have a problem where it doesn't have anything for a y-intercept, think about it as plus 0, right? So when I go over to the graph, right, I'll zoom out a little bit there. Let's scooch some of these a little closer, right? When I'm working on my graph, to put a y-intercept of 0 on there, that means that I'm just going to be putting it right at the origin, right smack dab in the middle, right? The y isn't going up or down at all for that intercept. After that, my slope is to go up 1 and over 1 from that point to get that blue dot there. And that's it. Then all we got to do is connect those dots and we are good to go. All right, so let's see if I can do that without dragging the ruler across the microphone and blowing out all your headphones. I'll try my best. Good enough. There we go. Cool. Line graphed. Done. That's it. Okay. Let's try another one of those out. Oh, same kind of deal, except this time it at least has a slope already in there for us. So my slope, right, is -3, which again we're going to turn into -3 over 1, right? So that we have a rise and a run to work with. After that, I got my y-intercept, which again, there isn't one shown there, so we can think about it as plus 0, and our y-intercept is that 0. Okay. On the graph, it's not going to be that much worse than the last one, right? My y-intercept is at 0, right smack dab in the center. My slope is telling me to go down 3, so 1, 2, 3, and over 1, right over to there. All right, so I've got my 2 points, connect them with a line, and then we're done on this one too. All right, we're really cruising through these. All right. For some of you, this may be something you've learned in the past, possibly in middle school, some other time, right? If it's kind of coming back to you and this seems easy, then that's awesome, right? That's not a bad thing in the least, right? We got one left. I'd like you to do is try this one on your own, right? See what you come up with. So pause here, give it a go, see what you know. So hopefully you gave that a shot, right? Same kind of deal as some of the other ones, right? Slope is right there for us. It's -6 over 5. Again, I suggest putting that negative sign on the top, but, you know. And then as for our y-intercept, it's that invisible plus 0 that's there. So my y-intercept is at 0. When I graph this, I'm starting at that 0 in the center. And then going to go down 6, 1, 2, 3, 4, 5, 6, and over 5, 1, 2, 3, 4, 5. And again, just like I mentioned in the past, that's -6, so we're going down. And then that is a regular old +5 on the bottom. So we go to the right towards the positive numbers. Last but not least, can't believe it's already over, right? We just need to, zoom out, I guess, make the line a little bit harder to graph. But then, yeah, graph that line on there, right? The good thing about zooming out is that it means that if I'm not as accurate, you guys might not even be able to tell, right? So, that's not bad. All right. And that's it, right? If you're feeling a little shaky on this, again, please make sure you ask when you see me. I am here to help. And as for now, that's it. See you later. Bye.